Words translated to symbols to enable quantitative communication. Words, introduction to fractions. In mathematics, fractions are symbolized as a numerical value, which expresses a part of a whole. All fractions contain a numerator. All fractions contain a numerator and the denominator, which are separated by a horizontal bar called the fractional bar. The denominator specifies the number of parts in which the whole has been divided into. It is placed in the under part of the fractional bar, whereas the numerator specifies how many sections of the fraction are represented or selected. It is placed in the part above the fractional bar. Now here we have a scenario. Mathematics translates words to symbols and diagrams also. Mathematics translate words to diagrams also. Here we have some English words outlining a situation. There are 4 children in a party, and as you can see, 4 is underlined because it's a quantitative word. It has its symbolic translation in mathematics. So there are 4 children in a party. 9 slices of cake. 9 is also a quantitative word. 9 slices of cake. Cake is not a quantitative word really. So, but if a word is not really quantitative in nature and it needs to be translated, a symbol can be created for it or a diagram can be created for it. So 9 slices of cake are to be equally divided. Both equal and divide have their mathematical symbols. Amongst them, how much cake does each receive? So we have 4 children in a party and we have 9 slices of cake. Okay, so how can we equally divide those 9 slices of cake amongst 4 children? Okay, therefore the task at hand is to equally divide, and here's a symbol for equal, divide, and here's a symbol for divide. 1, here's a symbol for 1 group of 9, here's a symbol for 9 cakes between 4, here's a symbol for 4 children. So I repeat, therefore the task at hand is to equally divide 1 group of 9 cakes between 4 children. Now this is very important there. The way this is phrased, 1 group of 9. The word of has a symbolic translation. The word of in mathematics is the times, represented by an X. Okay, so the multiplication sign represents the word of, especially in fractions. Okay, so therefore the task at hand is to equally divide 1 group of 9 between 4 children. So here we have 9 cakes. As you see, we can use a diagram to represent cakes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we have 4 children. We can use a rectangle to denote children. Okay, translating words to diagrams. That happens a lot in mathematics also. So let's give a child, each child a cake, because we want to equally share the cake amongst the 4 children, the 9 cakes. So let's, at first attempt, let's give each child a cake. So the first get 1, the second get 1, the third get 1, and the fourth get 1. So each of the 4 children have 1 cake, so that's 4 cakes shared already. 4 out of 9 is 5, so you have 5 more cakes remaining. So this process can be repeated because you can get 4 out of 5. Okay, so let's give each child another cake. And as you can see, only one more cake is left. So it is impossible to give each child a whole cake from that one. But this one more cake that is left can be sliced into 4 equal slices. It can be cut into 4 equal slices. All right, so let's do that. So we can give one slice. Here it is, as one slice, 2 slices, 3 slices, 4 slices. So this one cake is separated into 4 equal slices. So it is now transformed into these 4 slices, so we can delete this. So here's this one cake into 4 equal slices, so we can give one child a child. That's 1 out of the 4. So when I take this slice and give it to that first child, this is 1 slice out of the 4 slices. Okay, this 1 slice again I give to another child out of the 4 that was there. Okay, so each child gets 1 out of the 4. Okay, so each child gets a quarter and 2. Each child gets 2 whole cakes and a quarter of a whole cake. Okay, so therefore we can clearly say that a quarter, or let's start with the wording that was there and let's translate it to symbolic form. One group, let's make this a little bigger. One group of the symbol for office times. One group of 9, one group of 9 divided amongst 4. See that? That's the symbolic translation of this sentence there. One group of 9 divided amongst 4. Okay. Make this a little bigger. One group of 9 divided amongst 4 is the same as, so this can be rewritten a different way by taking this times 9 and put it here. So one group of 9 divided by 4 is the same as saying a quarter times 9. And a quarter times 9 is equal to 2 wholes, 2, and. Now the symbol for and in math is plus, in arithmetic especially. So 2 plus, or 2 and, right, 1 quarter. And this 2 plus a quarter can be rewritten as 2 and a quarter. You notice that you're saying and when you read this. You're saying 2 and a quarter. Okay, because it originated from here, from the plus. The word and in arithmetic, the symbol for the word and is plus. Bear that in mind. So in a nutshell, a quarter times 9 is 2 and a quarter. Okay, and that is the fundamental origin of mathematics, is to the whole idea of sharing, okay, a set equally amongst a group. A quarter times 9, here it is 2 1/4. Please be writing this. Make sure you have your pen and your pencil and your paper and your writing as you are viewing the math video.